Hi, I'm Ed Zynda, and this is What the Funk. Alright, what's going on YouTube? I'm back with another video, and in this video, I'm going to go over some best practices you should follow when you are building your Ethereum smart contract. But first, I just want to let you know that here on What the Funk, we talk about all things Web3 and smart contract development. If that's something that you're into, make sure to hit that subscribe button and click that bell notification icon so you can stay up to date whenever I post a new video. All right, let's get right into it. So Ethereum smart contract development hasn't been around for very long. So if you're already a developer or some sort of software engineer, the security and design concerns are going to be a little bit different than what you're probably used to. Because of the way smart contracts work, and because smart contracts exist in a highly adversarial environment, you're going to want to think about writing your code in a very particular way. It's not enough to defend your code from well-known vulnerabilities, but you should also design your code in such a way as to prevent vulnerabilities in the future. If you don't take these into consideration, the cost of failure could lead to millions or even billions. So without further ado, let's get into 5 best practices you should follow whenever you're building on Ethereum. Number 1. Expect the unexpected. The fact of the matter is, no matter how hard you comb your source code, no matter how many vulnerabilities you go over and try to prevent against, something can and often will go wrong. Your smart contract should therefore have fail-safes in place in order to counter this. So some good ways to counter this when things go horribly wrong is 1, have a way to pause the contract to keep it from operating so you can figure out what's actually going on and possibly push a fix. Another way is to manage the amount of money moving through your contract. So set limits and thresholds in order to minimize any sort of damage that could occur if your smart contract ends up having a bug. And finally, keep in mind an upgrade or migration path in case you need to fix some sort of catastrophic bug. Keep up to date. Now, once again, you could have gone over all known vulnerabilities when it comes to programming your contract, but in the future, somebody could have discovered something new. It's your job as a developer to keep track of any new security development. So as new exploits and security vulnerabilities are exposed, check your contract to make sure it doesn't apply to your contract. If possible, upgrade any tools or libraries that your contract uses. And if any new security techniques come out, apply those as well. Keep it simple. The more complexity you introduce to your smart contracts, the more likely there are to be errors. Try to keep any business logic concise and simple, straightforward. If you need to, try modularizing your smart contract into several smaller contracts to keep your functions smaller. Try to use pre-written and well-known tools in order to minimize reinventing the wheel. Especially in the beginning stages of writing your contract, opt for clarity of code over performance. Don't pre-optimize. And finally, only use the blockchain for parts of your application that require minimized trust and decentralization. If you can, try to calculate and move some of your logic off-chain. Number 3, test, test, test. It's always better to catch bugs before you go live. So the more you test, the more opportunities you have to catch something wrong. Write automated tests and aim to get at least 90% code coverage. If you can, 100% code coverage. Whenever you discover any sort of new attack vectors or exploits, try and write test cases for those against your smart contract. While this may not be possible for everyone, if you're part of a team and you have access to the funds, set up a bug bounty. Incentivize others to test your code for you. And finally, once you think you've done enough testing and you're ready to deploy in phases. Set limits and only increase those limits after each previous phase has been thoroughly tested and you've moved on to the next phase. 5. Know the limits of the blockchain. While building on Ethereum, there are some quirks and limits to the blockchain that you should be aware of when building your application. While it's possible for your contracts to make external calls to other contracts, it's important to be aware that those contracts can execute malicious code and change the flow of your contract. Understand that any public functions in your contract can be called by anybody and in any order. Also, that any data that you set as private in the contract isn't actually private and can be viewed by anybody who inspects the blockchain. Don't keep anything secret or meant to be encrypted in your contract. You should understand how gas works, gas cost, and the gas block limit as it relates to how your contract is called and run on the blockchain. Understand that timestamps on the blockchain are imprecise and that miners can actually manipulate the time of a transaction within the margin of several seconds. In other words, don't heavily rely on timestamps for something security intensive. Finally, don't try and generate random numbers on the blockchain. Random numbers on the blockchain are very trivial, and because of the deterministic nature of the blockchain, random numbers can be gamed by almost anyone. If you need random numbers, try and use some sort of oracle or commit review pattern. So to sum up, when you're building your smart contracts, you need to prepare for the worst, stay up to date with the latest security trends, try to keep your code as simple as possible, test a lot, and when you do deploy out slowly, and understand the blockchain and its limitations. If you enjoyed this video, go ahead and smash that like button. If you have any comments or questions, leave them down below. If you'd like to see more videos with breakdowns like this, go ahead and leave that down below in the comments section. Once again, thanks for watching, and I'll see you in the next video.